Welcome to The Explainer. Today we are diving deep into the world of risk, but probably not in the way you're used to thinking about it. We're going to look at why those simple color-coded charts that almost every company on Earth uses to prevent disaster might actually be making them blind to the biggest threats they face. See, in the 21st century, risk isn't some isolated event that happens over in a corner. Our financial systems, our energy grids, our healthcare, it's all one giant tangled web. And what that means is a tiny failure in one small part of that network doesn't just stay put. No, it can spread like wildfire with truly global consequences. I mean, think about that for a second. A single misconfigured server in Virginia taking down payment systems across 3 different continents. That's not some hypothetical what-if scenario. That's the world we live in right now. The real question isn't if something is going to break, it's how far and how fast the fallout is going to spread. Okay, so let's really dig into what makes this new age of risk so fundamentally different and, frankly, so much more dangerous. Just think about it. We have billions of devices, everything from the phone in your pocket to an entire city's power grid, all linked up in real time. Our whole society is now completely dependent on this digital backbone. But this creates a kind of hidden fragility, right? A single glitch can cascade across all these different systems and borders. And now, even our most critical infrastructure, hospitals, power grids, they're targets. So, how on earth do organizations try to manage this chaotic new reality? Well, they usually turn to their standard toolkits, their frameworks, starting with a really basic definition of what risk even is. Now, if you look up the official ISO definition, it's incredibly broad, and that's on purpose. It's not just about the bad stuff, the threats. It can also mean positive things, like opportunities. But hiding inside that simple word, uncertainty, is a critical distinction that most people and most organizations completely miss. So here's the crucial point, and it was first made by an economist named Frank Knight, way back in 1921. He said there's a massive difference between risk, where you actually know the odds, like rolling a die, and uncertainty, where you have no real data to go on, like, say, a brand new pandemic. And yet, most organizations treat them as if they're exactly the same thing. And this is the tool almost everyone uses to try and manage both, the risk matrix. Oh, you've definitely seen this before. It plots how probable something is against how bad it would be, and then uses some simple colors to tell you what to worry about. It looks so clean, so simple, and it's dangerously misleading. You have for sure seen a version of this matrix at work. It's absolutely everywhere. But while it looks all official and scientific, it has these deep, fundamental flaws that can blind us to the very disasters we're trying so hard to prevent. And this isn't just a rhetorical question, right? The fact that this simple little chart completely failed to predict massive, world-altering catastrophes like the 2008 financial crisis, well, that points to some pretty severe limitations. So where exactly does it all go wrong? Well, first off, it's completely subjective. What you call a high impact, I might call medium. It's just a guess. Second, it has this linear bias. It pretends the jump from low to medium is the same size as the jump from high to critical, when in reality, that last jump could be 1,000 times worse. Third, and this is the real killer, it has a massive blind spot for catastrophes. Those really rare, super high-impact events get shoved into a corner and basically ignored. And finally, those pretty colors create this illusion of control, making us feel like we've done the math, when all we've really done is put a label on a gut feeling. So if the matrix totally fails us right when we need it most, for the truly catastrophic events, what's the alternative? We need a tool that's actually built for them. And it turns out it came from a very unexpected place. This unbelievably difficult question was posed by the UK's nuclear industry back in the 1960s. They knew a simple red, yellow, green chart just wasn't going to cut it, and their search for a better way to answer this very question led to a huge breakthrough in how we think about risk. Instead of that simple grid, they developed this, the farmer curve. And it doesn't try to hide from catastrophic risk. It is designed specifically to visualize it. It plots the relationship between how often an event happens and just how bad the consequences are. So here's how it works. Along the bottom, that's the x-axis. We have the consequence. In this case, the number of fatalities. And this is so key. This scale is logarithmic, not linear. That means it can show the difference between 1 death, 1,000 deaths, and 1,000,000 deaths, all on the same chart. And then on the side, the y-axis, we have the frequency, basically how often an event of that size is expected to happen. And this axis is also logarithmic, which lets us compare things that might happen once a year with things that might only happen once in 1,000 years. And this, right here, this brilliantly illustrates the core insight. As the consequences get worse and worse, our tolerance for how often they can happen just drops off a cliff. Think about it. A society might tolerate 100 small accidents a year, but it will absolutely not tolerate one single accident that causes 100 deaths a year, even if some spreadsheet says the mathematical expected value is the same. The risk matrix completely, totally misses this. So you see, the crucial point here isn't just about swapping one chart for another. It's about fundamentally changing how we think and how we talk about risk. It's about moving away from simple labels and toward real wisdom. The true skill of a risk analyst isn't just filling in a color-coded box. It's being able to distinguish between these three categories. Is a risk probable, meaning we have the data, we can actually measure it? Or is it just plausible? We can imagine it, it's logically possible, but we don't have historical data. Or is it just barely credible, something that's only bounded by the laws of physics? Knowing the difference, that's everything. And all of this brings us to our final and, I think, most provocative thought. That line on the farmer curve, the one that separates what's acceptable from what's not, that line isn't a scientific fact. It's a social and ethical judgment. Deciding where that line gets drawn isn't a problem for engineers to solve in a lab. It's a question for all of us.